This tutorial is for 5th grade, Module 4, Lesson 30. In this lesson, we're going to divide decimals by relating the decimals to fractions and how fractions can be thought of as division. The directions say to rewrite the division expression as a fraction and then to divide. My first problem is 2 7/10 divided by 3/10. The first thing we did is rewrite this division problem as a fraction because as we saw in previous lessons, I can read this fraction as 2 7/10 divided by 3/10. So the dividend of my problem becomes the numerator and the divisor is the denominator. It reads the same way, 2 7/10 divided by 3/10. What this means is we're asking how many 3/10 does it take to make 2 7/10. Well, that's not as easy to figure out as it was in the previous lesson where we were dividing by 1/10 or 1/100th. So what we're going to do is we're going to multiply both our numerator and our denominator by 10. The reason we can do this is because, as we saw in previous lessons, when we're multiplying both our numerator and our denominator by the same number, we are creating equivalent fractions. So 2 7/10 over 3/10 is the same thing as 27 over 3. When I take 2 7/10 and I multiply it by 10, that means each digit is going to move one place value to the left. So if I have 2 7/10 and I'm going to move each digit one place value to the left, that would put the 7 in the ones place and the 2 in the tens place, and I don't have any decimal. So that's why when we multiply 2 7/10 by 10, we get 27. If I take 3/10 and I multiply it by 10, again, the digits will move one place value to the left. So the 3 ends up in the ones place, and I don't have any decimals. So that's why my denominator is 3. The reason I can change 2 7/10 over 3/10 to 27/3 is I multiplied the numerator and the denominator by the same number, and that means the fractions are equivalent. So I haven't changed the value of the fraction, I've just changed how it looks. Now I can read this division problem as 27 divided by 3, and I get a final answer of 9. That means that 2 7/10 divided by 3/10 equals 9. Let's look at the next example. This time I have 2 7/10 and I'm dividing it by 3/100ths. Again, the first step was to rewrite it as a fraction, 2 7/10 divided by 3/100ths. This time we're multiplying the numerator and the denominator by 100 because that's what's going to get my 3 into the ones place. If I multiply 2 7/10 by 100, now my digits will move 2 places to the left. So the 7 will end up in the tens place, the 2 will be in the hundreds place, and now I have to fill in the ones place with a 0. So that's how I got 270 for my numerator. To multiply 3/100ths times 100, again, each digit will move 2 places to the left, and that puts my 3 in my ones place. So that's why I have 3 for my denominator. Now I read my fraction as 270 divided by 3. Well, 3 times 90 would give me 270. So 2 7/10 divided by 3/100ths is 90. Let's look at the next example. This time I have 3 5/10 divided by 5/10. I'll start by writing it as a fraction, 3 5/10 divided by 5/10. Now I need to multiply my numerator and my denominator to get whole numbers, and I'm going to do that by multiplying them both by 10. So 3 5/10 times 10 and 5/10 times 10. Because I'm multiplying them by 10, that means each digit will move one place value to the left. That means my fraction is now 35/5. Each digit moved one place value to the right. Now I read this as a division problem. 35 divided by 5 equals 7. So the answer to 3 5/10 divided by 5/10 is also 7. In the next question, I have 3 5/10 divided by 5/100. I'll start by writing it as a fraction, and the way I would read this is 3 5/10 divided by 5/100. To get my whole numbers this time, I'm going to multiply by 100. That will make sure that I have a whole number for my denominator as well as my numerator. So we'll take 3 5/10 times 100 and 5/100 times 100. Each digit will move two place values to the left now since I'm multiplying by 100. If I move this two place values over, that means I'll get 350. If you look, I'll show this on the place value chart. I'm going to take 3 5/10 and move each digit two place values to the left. That will put the 3 in the hundreds place, the 5 in the tens place, and then I have to fill in the 0 for the ones place. And if I move my 5 two digits to the left, that would put it in the ones place. Now my problem is 350 divided by 5. Well, 5 times 70 will give me 350 as an answer. So 3 5/10 divided by 5/100 is 70. And that means it takes 70 5/100 to make 3 5/10. Let's look at one more set of problems. The first one is 4 2/10 divided by 7/10. I'll write it as a fraction, and we would read that as 4 2/10 divided by 7/10. I'm going to multiply my numerator and my denominator by 10 to get whole numbers. So I have 4 2/10 times 10 and 7/10 times 10. Since I'm multiplying by 10, each digit will move one place value to the left. 4 2/10 becomes 42. 7/10 becomes 7. Now I read this as a division problem. 42 divided by 7 equals 6. That means it takes 6 groups of 7/10 to equal 4 2/10. And my last problem. I have 42 hundredths divided by 7 hundredths. I'll write that as a fraction. And we would read that as 42 hundredths divided by 7 hundredths. This time I'll multiply by 100 to get whole numbers. So I'll take 42 hundredths times 100, and I'll take 7 hundredths times 100. Since I'm multiplying by 100, each digit will move two place values to the left. So 42 hundredths becomes 42, and 7 hundredths becomes 7. Now I just have to read this as a division problem. 42 divided by 7 equals 6. This time it takes 6 groups of 7 hundredths to make 42 hundredths. We can use the same strategy to solve word problems. The first problem says Mr. Volo bought 2 4/10 kilograms of sugar for his bakery. If he pours 2/10 of a kilogram of sugar into separate bags, how many bags of sugar can he make? I'm going to start by writing an answer statement so I know the goal of the problem. I'll say he can make blank bags, and I know that each bag will have 2 kilograms of sugar. So the problem we're doing here is we're taking the whole, which is 2 4/10 kilograms, and we're going to divide it into groups. Each group will have 2 kilograms of sugar in it. The question is, how many groups do we have? We'll start by turning our division problem into a fraction. So I can look at this as 2 4/10 over 2/10. I would read that as 2 4/10 divided by 2/10. I'm going to multiply my numerator and my denominator by 10. That will give me whole numbers. When I multiply by 10, I shift each digit to the left one place. So now I have 24 for my numerator and 2 for my denominator. I'll read this as a division problem. 24 divided by 2 equals 12. This means that he can make 12 bags of sugar, and each bag will have 2/10 of a kilogram in it. Here's a follow-up question. This time he's going to pour 4/10 of a kilogram of sugar into separate bags. Now how many bags of sugar can he make? We're going to start off the same way. We'll start with the whole, 2 4/10. We're going to divide it into bags that have 4/10 in each bag. And the question is, how many bags will he use? We'll write this as a fraction, 2 4/10 over 4/10. I can read that as 2 4/10 divided by 4/10. I'm going to multiply the numerator and the denominator by 10 to get whole numbers. Now my fraction is 24 fourths, or I can read it as 24 divided by 4, which equals 6. Now he can make 6 bags, which makes sense because he's using twice as much sugar this time around. If he made 12 bags last time, he would make half as many bags, or 6 bags, this time. So you can see how relating our division problems to fractions helps us divide decimals.